now. Hold on.
Great, and I'll do a quick introduction once you start streaming.
It is started, so go for it, Ben.
Great. So we have these sessions once a month. This is the focus follow-up. This is
we just lost your audio, Ben. You're muted.
Great, and I'll do a quick introduction once you start streaming.
Right now, somebody has the stream going in the background now, so you got to mute that, please.
So we have these sessions
Vivek,
once a month. This is
Vivek, I think that might be you.
This is,
sorry.
Yeah, you got to mute that. Okay, Ben, and you need to unmute because I think you got muted while you were speaking.
I'm still hearing a whole echo chamber.
No, that was Vivek had the stream playing in the background, but he's muted now, so we should be good. You might have the stream going in the background, so you might need to close that tab. You should not have that going, just the Zoom app.
All right, I think we are finally out of the echoes. Okay, so we do these sessions once a month. It's the focus follow-up. It's the fourth Friday of every month at 1 p.m. Eastern time. Today, the presenter is Alexander. He's going to be sharing some tools and tricks from Fusion 360, and I'll pass it over to you. And I apologize for the technical delays. It's been a little bit of some hoops to jump through, but here we go.
Alexander, you're muted.
Of course I'm muted, and I've been talking this entire time. It's fine. Every time, I swear. Right. So presentation on Fusion 360 on the basics and some very starter-friendly advice for those that are just starting with CAD modeling and 3D printing. Right, so a little bit about myself. I have been a part of e-NABLE for a couple of months, helping with the design and making of a new hand. I have a robotics BEng degree that I have just finished at Plymouth University. I have been playing in Fusion for about 8 years now, and I am technically an advanced user. However, I am not a professional user, so there might be the case that that you actually know more than me. These are just my tips and tricks of my experience. Right, so what is Fusion? Fusion technically is called a computer-aided design and computer-aided manufacturing software. For our purpose, it means you can model 3D things in it as a professional engineering tool. So it's not something that you design animations in for video games or anything like that. This is specifically oriented on engineering. How do you start using it? Fusion 360 does have a free educational license. However, it is a downloaded software and one that's that can be quite heavy on your computer. So if you don't like using Fusion or you don't have such a powerful computer, there are plenty of in-browser alternatives. The most recent one that I've heard of is Onshape. And tips and tricks that I'm going to be giving off today do apply for almost all CAD software. A bit of insight into the so-called classes of experience when it comes to computer designing. You have the beginners, so under 50 hours of experience where you just play with shapes and you're not really perfect. You have the amateurs, which start using less schematics and start looking better, the designs in the end. Then you have the advanced, and that's where I'm currently at. Where you start looking into parametric designing, more engineering professional tools and stuff like that. You have the professionals, which are actually paid. And then you have the mythical classes of the experts and the special class. The special class, and this is just classes that I really made up based off my experience with the community. The special class is the people that are making scripts and mod your CAD experience to enhance it, to make it better or make it appropriate for other uses than the standard one. A number of advices for when you're starting, when you're just starting modeling. Technically speaking, the moment when you design and print even a simple cube or your most basic shape, it does count as manufacturing. So congratulations on your first prints. Do ask questions. There are no stupid questions. There are only questions that you yourself don't understand quite properly yet. Write down all of your ideas. A lot of ideas for most people come in the shower, in the bathroom, on the subway, or stuff like that. Write down all of your ideas so that when you're actually getting to the computer, you can glance over them and figure out which one was the best. And on a similar topic, draw your ideas on paper. Using CAD, no matter your skill level, means you have a decent enough image of the final product in your head. And to do that, especially with the most complicated designs, you have to have a design that's made on paper. It doesn't have to be easily understood by everybody. As long as you understand it, that's more than enough. And do remember that the difference between messing about with various toys and doing science is just documenting it. So document all of your work if you mean to actually share it with somebody else. And with 3D printing wasn't designed as a toy, it was designed as a manufacturing environment. So on one hand, don't be afraid of iterations and failure. They will occur, and that's a good thing. That's an opportunity to learn. And there will be a lot of failures, even for the most simple things. But because of how the software is designed, the computer-aided design software, there is no right way to model a project. There is no standard way of making a cube. There are 1,001 different ways to approaching every single project. And there is no, this is the way to do it. There are plenty of ways. You just have to have the imagination to think of them. Right. A bit into the more practical side of the presentation, the basic tools. So for using Fusion 360, we have for the making part, the Extrude, the Sketch, and the Revolve. Let me find, there we go. So you have the Extrude, the Sketch, and the Revolve, and we're going to look at all three of them. Sketch means you are making a two-dimensional design. And this is where it actually counts a lot if you've made your design on paper. And I am actually going to download a design in a second. For this presentation, I'm going to present how to make a basic skeletal looking finger. And I just made some really simple sketches on paper. You might not even be able to understand what they're all about, but the only thing that really matters is that I understand them. Let's see. We have to find a canvas. And this is the side note of making. Use plenty of canvases. If you have drawing on paper, you can put the drawing in here as well. You can insert them from your computer, and I just downloaded this. Let's say I'm putting this on this face. And I need it to be 180 degrees, so it's face up. Right, so on top of this canvas, we're gonna use the sketch environment. So to start the sketch environment, you can start it from here, or you can press L, which will automatically start the sketch environment, and it will ask you to select a plane where you wanna sketch your things. And if you're using L, it will automatically select the line tool. Now, there are a bunch of tools over here, and I really encourage you to explore all of them. Some of them are advanced, some of them are not. So in our case, we're not going to be using this this picture right here. We just want to create a very simple rectangle. We're going to click Finish Sketch, and that's the sketch so far. Now, in order to make this a three-dimensional object, we're going to click on Extrude. And then we can pull on the arrow to make it as big as we want. You can also type in here the exact measurements that you would like for your thing. And with Control Z, you can undo the last movement, and you can undo all of the movements that you've made so far. And that is the extrude and the sketch command. With the extrude and the sketch, in the beginning, you will probably be able to make about 90% of your designs easily. Now, the revolve command is functioning. It's very similar to the extrude in the sense that it does extrude, but it does require an axis of rotation. And here, for example, I have selected this rectangle with the revolve command, and I'm going to select as the axis this line right here. And as you can see, it rotates the entire profile 360 degrees. Now, if I don't want the full rotation, I can also select a specific angle that I want this at. Let's say I want to make a Pac-Man right here. If, for example, you want to make a sphere, you would have to draw a circle and then draw its diameter so that you can revolve one side of the circle around the diameter 360 degrees, like so. And now you have a three-dimensional Pac-Man. Those are your basic tools, and I will be showcasing them a bit more in a minute when we're actually going to have a proper demo for the skeletic finger. Now for the checkup tools. Once you have finished your designs, you will want to make sure of certain of how the design looks inside, of how the design might be measuring from one point to another. In order to get the section analysis, which is really common to be requested in engineering, you would have to go with Inspect, and then down here you have the section analysis, and select a plane. And as you can see, it will cut all of the objects in the scene and show you the section view. You can also angle the section view, and you can use the arrows to move about. This is really relevant where you have designs that intersect a lot of components. For example, on this finger that we're going to be building in a minute, I have this section view that shows how the components actually fit together. And you have different colors for each of the components. Now, the other thing that's really useful for checking your design is the inspect functionality. You can turn off the analysis from over here. And for the inspect functionality, you have this measure. Now, measure can also be called from the keyboard by pressing I. And you can select, let's say I want to see the diameter or the radius. And so I click on the outside edge of the circle. And that's going to give me the diameter, the radius, and anything else, including, for example, the length. I have no idea why it gives me the length. If I want to see, for example, the distance from this side to this side, as you can see, it has some visual feedback. And it will also show me over here, selection 1 area, selection 2 area, and you have the distance and the angle between the two surfaces. And the measurement functionality has a bunch of different modes of operation. For example, you can select faces that are not exactly aligned. and you will get something like this. Or you can select faces and try to get their angle between two different faces, and there you go. You can see it's 40 degrees apparently. And all kinds of stuff like that, which again is really useful when you try to make something that you're 3D printing in the real world. Now, corrections. Let's say you have checked your design and something is bad with it. Now, if you've noticed, for the time that we've played in here, there have been popping up some small things in here. This is called the history design. Oh, sorry, design history. And this is by default, this is on in Fusion. Now you can also, you can Control Z to remove some of them, but you can also roll back the history. So for example, if I roll back the history, then I can edit this part and it will automatically compute the entirety of the history. This is not relevant in the beginning, but it will become relevant as you start gaining experience and you start making objects based on other objects. Another important feature is you can double click a sketch from the list of sketches in order to edit it, and it will also jump the design history to that point. So for example, if we want to edit this one, we don't have to go all the way back here. We can also double click on it, and now we can start adjusting it. For example, we can make it much longer and a bit more slim. If I click finish sketch, there you have it. It automatically applies the changes to the entire design history. You can also make the bodies invisible. You can select which bodies are visible. You can select which sketches are visible. And well, really, you'll get to your own preferences in that part. Personally, I prefer to work with only one body and only one sketch at any given time. But I've seen people working with 50 sketches. And another type of correction is the movement and alignment. Now you might have two discs like this. So I hit E for extrude, and I'm gonna make another body. And now I have two discs, but I want to have a small distance between them. I don't want them to be completely flush with each other. So I can select the body, right click and move. I can also press M on the keyboard. And now I have the entire move functionality. Now this has a bunch of different modes of operation, and each of them has their own use case. But the default one is this one with the arrows and the angles. Do keep in mind that when you're trying to angle something, it will angle it by this point. So if, for example, I'm selecting another point over here, it's gonna rotate it about that point. So that's, for example, for that, you have to select the very center of the body. And you can also select stuff from a sketch. So for example, I can also select this point, if I'm not mistaken. Not even sure how to do that. If you find this menu to be too much, you can also select just the translation menu or just the rotation menu. For the rotation menu, it's not 3-axis, so it's not all 3 axes around the random given point. You have to select an axis of rotation. So this is for very specific rotations. And there you have the axis of rotation from the previous sketch. The axis of rotation doesn't have to be from a sketch. It can also be from a given object. So it can also be this part. And now I'm rotating around its own center. And that's pretty much all the basic tools that you're going to be using in your first probably 50 hours. The other thing that's important for for using this in the e-NABLE community is how to export this to a 3D printer. Now, Fusion 360 does have some embedded connections with Ultimaker, but personally, I don't have Ultimaker, so I didn't bother with them. You can select one of the bodies, right-click on them, save as STL, and you can select your refinement from over here in case you want a custom refinement or you want the file to be really small. And it will ask you where do you want to save the file. And from there, you can directly import it into your preferred 3D printing environment. Right, so those are the basic tools. Now for a bit of a more proper demo, we're gonna be running on this depending on time. I can see I'm already halfway there. So we're probably not gonna be able to run through all of the approaches, but we're gonna be redesigning this finger based on this canvas right here. And to remove everything but the canvas, I'm gonna roll back the history, right click on it and delete all features after the history marker. In order to make the canvas millimetrically with a millimetric precision, you can right click on it and click calibrate. And you can have, for example, I have the diameter of this hole about 3 millimeters. And now when you're doing sketches based on this, your entire thing will be scaled up. A quick word about the most basic approaches for each skill set. The beginner level, you can have lots of shape and sketches, and all that you care about in the beginning of starting to use Fusion is getting the job done. You don't care how many shapes and sketches there are in there. Once you will get more experience, you will start wanting to use less sketches, because you will want to edit those sketches in the timeline to edit the entire design. On an expert level or on a more advanced level, you would start using parametric designing, which basically is using parameters, which are predefined variables that you're going to be using in your designing. For example, I can have a parameter that specifies that all the holes in my design will be exactly 3 millimeters in diameter, and that's called a parameter. Just to showcase it, I can click on modify, change parameters, and I'm going to create exactly that variable, hole diameter, and I'm going to have it have 3 millimeters. And you can have however many parameters you want. You can also create these parameters afterwards, and you will have to find them in the history in order to edit them. And then you have the professional level, which is not just a parametric design, it's also a printer-friendly design. And that's more regarding the actual manufacturing process. So for everybody that's either in Zoom or on YouTube, which level do you wanna see approach right now? For the people that are still watching, that is.
You know, I'm interested in the oh, looks like we've got beginner.
So absolute beginner.
I'm also curious in how it ties into the printers, and that would be probably a discussion for where Jeremy could jump into. So that maybe we can end with that. That would be wonderful to maybe even just walk through it. It looks like Susanna is asking about amateur. So is it possible to maybe give us a little tour?
All right, let's try to finish the finger really fast on the beginner level, and then we can talk about the expert and professional level. Is that all right?
Perfect.
All right, so let's see how would we design. We have this finger, and I have it in real life besides me because I made a bunch of models of this. And this is an actual finger that we're currently developing with the e-NABLE collaborative team. Granted, not this one. This one has way too many holes. So in my imagination, and as you can see on the sketches here, we can have three objects. We have the finger mount, which is this part. Then you have the middle phalanx, something like that. And then you have the tip. And theoretically, from what I thought, you can have the wires connected from the first body going through the second body and tying off on the end. We're not going to care about the wires right now. We only care about making the bodies first, because the wires can be added later. So in order to have a finger mount right here, the way I thought it was firstly creating a sketch over here, creating a massive axis so that everything will be symmetrical on this axis. And now we're gonna have a bunch of lines over here with, let's say, 2 millimeters of width. And then a bunch more lines over here. And that's the basic finger holder. We're going to revolve this around this axis. And now you have something to put your finger in, which sounds terribly wrong. We're going to go ahead and edit the sketch from over here. Simply because we could create another sketch, but there is no point in it right now. And for the connection right here, we're going to use a rectangle. And rectangle, the hotkey on the keyboard is R, and the hotkey for a circle is C, which you can also see right here. Let's say it's somewhere over here. We want to use that, that parameter. So we're going to start typing it hole, and there you have it, hole diameter, and hit enter. And as you can see, it's not a dimension, it's an fx. So that's a function. Functions can be a lot of things, but that's a topic for a more advanced session. Also, if you have a line that you would like to make smaller or bigger, you can either A, drag your points around, or B, hit D for dimension, which you have on the top right here, and put a dimension on it. And then you can write a different dimension. Do keep in mind that the blue lines can all be moved around. However, let's see, the origin of the file is right here. So if we create a line right here, this is poorly defined, and you can see it as blue. If, however, we start defining things about it. So for example, we can put a dimension on it. So that's exactly 17 centimeters. And then we can put the other dimension on it, which is going to be 10 millimeters. Oh yeah, we're in millimeters, not centimeters. You can see the line just became black. That's because this is defined well enough that you cannot move the points around.
So Alexander, this is Connie. Sorry to interrupt. Do you always fully constrain your sketches, or do you leave them?
If you have the time and the application, always try to fully constrain your designs.
Okay, perfect. Thanks.
Something that's not constrained would mean that it can be moved around. And when you start moving things around, when you have very complex sketches, see right here, I've moved the circle, but apparently the circle is constrained to the line, and now I've messed up the entire design. And that's why you prefer to have these things constrained. There is also, for the advanced users, you can select parts of the sketch and hit on this fix and unfix, and this becomes unmovable. And it's very similar to having a constrained line. But again, that's for more advanced users. Right, so we have the basic thing. we have the basic finger mount. If we select to view the old sketch and make this body completely invisible, we can select these things to go from left to right. We're going to select two sides. We can actually select symmetric. So it's going to be exactly 5 millimeters in each, on both sides. We want to see this object. And when you see that the extrusion is red, it means it's set up to cut. And if we hit enter, it's going to cut that profile into your old objects. As you can see, it literally cut the tip off right here. Now, if you want to edit that, double click on the extrusion in the timeline and we can select it to join. You can also select to make a new body or have just the intersection right here, which would be the tip. But for our purposes, we want this to be joined. So now without the canvas, we have the finger mount and the connection. Going back to the sketch. We want these two planes. So we have this object and we have these two side parts of the joint, and we want to create those. Now we're going to use again extrude for this, but we're going to use it with an offset. So I have my body right here and I have to guess pretty much the offset because Fusion doesn't have a proper enough setting for this yet. So let's say I want this to be joined and I want the offset to be 3 millimeters. So it's moving the entire thing on the direction of the extrusion. And since it's already offsetted by 3 millimeters, I want the actual extrusion to be 2 millimeters so that it's flush. And you have 1/2 of it. And you can also do the other half. Now, in order to do the other half, because I'm lazy and I don't want to make another extrusion, I can also use mirror. Now, mirror, as the term says, it will mirror whatever you select. You can mirror faces, bodies, features, or components. Features are things that are right here in the timeline. I'm going to select features, and I'm going to select the last extrusion. And the mirror plane is going to be the sketch. So it's going to be this mirror plane. And the compute option, we don't really care about that. So if we remove the canvas, there you have the joint connected to the first body. Now, if we go back to the original sketch, this is rotated downside. It does happen every now and again. Don't worry about it. You can use this cube to orient the entire design. Or if you want to spin everything around, you have to shift and middle click and drag the middle click around the screen to orient your view. I'm going to go a bit faster right here, simply because we're going to be running out of time. So we have the connection. Then we have another joint right here with another hole. We're going to use the specified diameter. Hit enter, and then we have the tip. Finish the sketch. And now for the object that I have inside here, as you can see, I thought of it to be between the two planes. In order to do that, you can do really two things. You can either extrude this specifically to that destination, or you can start the extrusion and click on the plane that you want it to be towards. So as you can see, it shows besides my mouse, snap to. By default, this is going to try to join it, but we are going to have a new body. There is a difference between new body and new component, but we're not going to go into that right now. And we don't want from the middle to this side. We will want from this side, new body, to this side. And again, it automatically selects join. We're going to select again new body and be done with it. And now we have two bodies in here. If I make the first body invisible, you can see this is the second body. We're gonna go ahead and extrude this other thing symmetrically and have the measurement up to this size so that it automatically snaps to the desired location without actually us having to figure out, oh, wait, this was 3 millimeters or whatever. Right, and this is the second body. Now for the third body, on the original design, we have something that is very similar. So the third body is going to be on the outside planes again, and then with a sticking out little thing on the front. So we're going to make the sticking out bit first. Again, symmetrically. We want to view the last object as an object of reference. And let's say it's going to be this big. And we're going to have a new body again. Now we have two things. We can either use the original sketch, or let's show you how to do a new sketch. We don't have the canvas. We have just these two bodies. We're going to hit L for line, which is automatically going to try to start a sketch. Hit on the side that we want to sketch about, and hit C for circle. And you have the circle of this surface right here. Finish sketch. And now we can start extruding this and connecting this to the second body. Now, this part is technically connected to body 2 and body 3, which are numbered as 5 and 6 for some reason. In order to connect it to just to body 3, we can select to unview to make invisible the first body. And now it will only connect to the second body. And we're going to be doing the same on the other side. Make the first body invisible and join with the second body. And there you have a very, very simple prototype of a finger. We are probably going to be running out of time soon. So what questions do you have regarding the more advanced design?
Just keep in mind, Alexander, we had those technical difficulties, got a bit of a late start. So if you want to, run to, if we wanted to 10 or 15 after, I don't think that would be a problem.
That's perfectly all right with me. There is the issue that using the beginner method of having lots of shapes and going really slow will probably not allow us to even finish this this design.
Alex, I think it may be informative for you to just demonstrate the export of an STL file, just so people understand what the end game looks like. The other thing you might show is just how you can manipulate the joints so that they understand that this is also a modeling, a simulation environment.
All right, let's go first with the STL exporting. Now, my preferred printer environment is Prusa Slicer, which is, of course, free. If we want to export these things, as you can see, there are 3 bodies right here. So we have to export each of them individually. And let's say I'm going to export all of them in on the desktop. Right click on it, go to Save as STL, and then select your refinement, your format. If you don't know what those are, just leave them as they are by default. And hit OK. And then you can go in your 3D printing environment. And you can select multiple bodies. And you have them on your build plate. We should probably be making a tutorial on how to use various 3D printing software and the supports, but that's not part of today's workshop.
Thank you.
All right, this is how you import them in your software. I'm gonna close that. And the simulation part, which is really important, but I don't recommend it for beginners. If you want to simulate something that is actually moving, there are a number of types of joints. And in order to access a joint, you have to have assemble and joint. It's not going to let me do any joints because there are no components. You need to create a component or convert existing bodies to components. There are a number of differences between bodies and components. Probably the biggest one is that components can contain bodies. If you don't want to bother with that, right click, create components from bodies, and it will automatically create a component for each body. Now, a single component can contain a number of different bodies and a number of different joints. A component is like a different design file, essentially. Right, once we've created the components, we can also name them. And if you have more than 3 or 4 components, I strongly recommend naming each of the components. And this is going to be the finger. And I'm going to have assemble. Joint will try to move the 2 components about. And you can also have as built joint, which will not try to move the components about, which I'll showcase in a bit. Let's see, I have to select the first component. Okay. I'm going to select this body. Right, so it's joint. Oh, I have no idea why it doesn't work. Right, so apparently I have an issue with fusion to edge intersection. Let's say for now that you can also select a face, and we want a rotational joint between these 3 bodies. So we're going to select this part of rotation. You can see a small yellow thing that tries to snap around as I move my mouse around. If you click once, you're going to select the body that axis was part of, and then you have to select the slave. So the first component is going to be the master, and the first component is going to be the slave, and the second the master, meaning that the first component is going to move in relationship to the second component, which is an important distinction when you actually want to derive movement all over the finger. As you can see, by default, it tries to move the 2 spots so that they touch each other. So we have to move it back, and we have to select the type of motion, which is going to be a revolute joint. And once you select revolute, you can also hit animate, and you can probably figure out if you've done a proper job selecting the joint or not from this animation. There are 6 types of joints, but probably you also have some joints that are a combination of them. You have the rigid joint, which means the 2 bodies are separated in files. However, they act as one. You have the revolute joint. You have the slider joint, for which you select an axis on which the first object moves around. You can also select the sliding axis from over here. So if I select the x-axis, we have this snapping point right here. And when it's animating, it goes front and back. You can have cylindrical, which is how a screw moves. You can have the pin slot, which is a pin in a slot, but it's harder to demonstrate right now. You can also have the planar, which means that it can move in 2 directions however it likes. You can have the normal right here and the slide, and it allows rotation in that specific plane. And you can have the ball joint, which is two revolute joints connected. For our case, we're just going to be using a simple revolute right here. And we're going to press J for another joint. Have the second body be invisible. Select this, this point right here as the snapping point. Make the second body visible again. And now I can select this point as well. And this way it won't be moving around because the two snapping points are on top of each other. By default, the joint selects the last motion, but you can also select a different motion easily. You can also have various offsets. For example, for revolute, if I select this offset, it's going to move like so. I don't really recommend tinkering with offsets if you don't know exactly what you're doing. And these are the joints. Now, where the heck are they? They are right here in the design history, and they will be creating a new folder right here called Rev1 joints, and you have Rev1 and Rev2. And it also shows the exact angle. Now, if you double click on one of them, you can highlight it in the environment. And if you right click on it, you can drive the joint manually. So for example, I want to move it exactly 90 degrees this way. And if I hit enter, I also have to hit capture position. So that is now how the computer sees the design. This is no longer an animation. I can actually create a sketch from this point to anywhere else. Otherwise, if I don't capture the design, let's say I am driving the joint again, hit OK. And now that I'm trying to hit L and making a sketch, it asks me, do you want to capture the current position or not? If you hit continue, it's going to rotate to the previous position. In order to test if the things move smoothly, so a proper contact simulation, you can hit on assemble, enable all contact. And now I can also use the drive joint command. And it doesn't want to move because the two objects are intersecting. If I try, the two objects are intersecting in, we're going to make a section analysis. There we go. The two objects, oh, they're not intersecting actually. And this is why a section analysis is useful. They actually have no place to move because of this little square thing. So that's going to stop everything from moving. I'm going to cancel the analysis and try to make this other joint move. Double click on the marker or on the general view, and you're automatically going to get into the drive joint. And now I can actually move the joint until it hits that other object. And that's how you can very roughly simulate contacts. As you can see, it doesn't go quite all the way because of how the engine is designed, but it's more than enough for most of your simulation cases. If you want, for example, we're using wires in the finger, so we might want the two joints to be connected to each other, so that if this joint moves 90 degrees, I want this joint to also be moving 90 degrees. We're going to disable the contact. Well, actually, no. We're going to have enable all contact, and we want to edit that little thing that stops us from moving. Now that little thing is part of this. In order to find something in the design history that you're not sure which extrusion it was, simply click on it and it's going to highlight the object that it modified. So the last extrusion, for example, was this one. If we modify the second extrusion right here, it needs to be without this part of the circle so that they no longer intersect. And let's check that it actually did what we wanted through the analysis. And yes, they no longer intersect. They are just flush with each other. So technically, I should be able to drive the joint around. And there you go, we can drive the joint around. If you want to connect these two joints to move together at the same pace, you can have a motion link where you're going to have to select the two joints, and you can have the normal rotation or the reverse rotation. You can also select a specific type of ratio from over here. So you have, let's say 180 degrees to 360. So one of them will be moving at double the time. Now, let's say we don't feel like moving them manually. We can also hit animate joint, which will only animate the joint. If we go with animate the model, it will animate the entirety of the model. In order to not get this error where things are starting to pop off everywhere, we can either disable all contact and animate the model again. And as you can see, it's a 1:2 ratio with a reverse rotation on the second joint. Or we can still have the contact and start getting joint limits. So each joint can have a minimum and a maximum and the resting position. If you feel like declaring them as degrees, you can go through this menu. If not, you can just drag these things along right here. And now if I try to animate just the joint, not the entire model, it's gonna go to those limits. And those limits don't have to be the physical contact limits. They can be much smaller. So for example, I want this part to only be moving about this much. And it's only moving that much. I can also select some, I can also right click directly in the view here and have the joint limits, minimum, maximum, and let's say I want 30 degrees in each direction. The minimum always has to be smaller than the maximum. And if I hit animate, there you have the movement. So let's try to simulate the entire model now. Of course, it cracks because this is supposed to move 2 times faster than this one. So I have to edit this to be at the very least more than 15 degrees, let's say 25 degrees. There is a separate issue. The amount of the range of motion of this one, because of the motion link, has to be smaller than the second one. So for example, 10 degrees on each side. And as you can see, it barely flops around, but it does flop around with only one movement. And we do know that the movement is possible because of enabling all contact. It is also written over here. You can also use contact sets between different bodies so that it's not trying to compute between 1,000 bodies. But again, that's only the case for very, very complicated designs. Any other major questions, either from YouTube or the Zoom chat? No, nothing?
Alexander, I'm curious about, this is Ben. I'm curious about preparing a file for printing, about your process. So maybe you can talk briefly about taking something like this and preparing it for the printer.
Well, to prepare something like this for the printer, there are 2 major ways. Number one, you can go directly in your printer environment and start putting supports everywhere. Or number 2, you can start thinking about how to make the printer's life easier. Basically, the printer is a very, very patient kid with a glue gun, putting layers upon layers of glue. Now, for example, in here, when you're putting layers upon layers of glue, here you're going to be putting hot glue in midair. So that might be a bit rougher. That in 3D printing, that's called the bridge. This bridge over this gap is not big. However, this bridge over this gap is quite ginormous. If I'm not mistaken, I'm going to hit measure. And on this line, it's 20 millimeters, which is probably at the best case scenario for my 3D printer. So we either put supports under this, or we figure out how to make the printer's life easier. And there are a number of ways. My preferred way, for example, is thinking, how can I print this? So I have just one object. How can I print this without having any bridges? And the easy answer is just print it on this side instead of this side. If that is not a possibility, for example, with this part, we can print it on the sides, but we would have this entire thing in midair. There are two kinds of bridges. There are bridges that are supported on one side and bridges that are supported on two sides. If you have bridges that are supported on two sides like this one, that means the biggest droop is going to be in the middle. And after that, the line is going to connect to the other supported side. And that's the better case of a bridge. If, however, you have bridges like this surface, where you have a side that's completely in the air, there is a good chance that this will completely droop over to another level. So all the way to this part, and this the end result is going to be that this body is going to be completely unusable. In order to make it more 3D printer friendly, we have to figure out a way for the 3D printer to print this without major supports. I'm going to import the model right here because it's easier to move around. So this is the model. If we try, for example, to print on this face, well, this is not too bad. Technically, we don't have any bridges. And we have a bit of printing in midair right here. But since this is less than 45 degrees, this should be just fine. If this isn't the case, we can also look at other angles, for example, this one. And this would mean that it has a contact point over here and a contact point on the radius of the thing. Now, we want to increase the number of contact points so that it has more support. So one way to do that is to go and create a sketch right here. Really simple sketch. We should make this tangent. We're gonna hit, this is the constraints menu. It's the same menu with the sketches, but this deals with constraints between shapes. And we're gonna make this line tangent to the circle. We're gonna hit E for extrude, select that face, and bring it over to the other side. We can now right click on this, save as STL, and this will save the entire component, no matter if it contains one body or more. Hit OK. This is body 6. And now if we import it alongside, we can angle it again. And when I'm actually slicing, as you can see, much less bridges. I have the bridges, I have the overhang perimeters with blue. And this design right here would require supports. Well, if you don't
mind, I just want to point out one thing here. That another consideration as you're setting up your prints is also going to be thinking about the direction of extrusion. So the way Alexander is showing this is perfectly fine. It's an option, but if you really want to get the maximum strength from this part, because this is a point of stress, I would print this with the circular faces flat side down. And yes, you would need supports on the inside, but that's no big deal because they break away afterwards. But that way, the direction of the layers, you're going to have full concentric circular layers that are going in the direction of those circular faces, and you'll get better strength on that part as opposed to the layer lines going across like they are right now.
Right, and this is a completely different a different level of thinking, really, because this is professional manufacturing. You have the strain. Let me share this. So you have, this is how it would look in a cross section. You have the layers right here. And if you pull the layers from the tips of them, it's going to be just fine. You're going to have the maximum amount of force that the material can take. However, if you try to pull the layers apart, the layers aren't perfectly binded together. And that's part of the 3D printing technology that you have to understand when you start doing more professional work. And because they're not binded together perfectly, it means it's easier to pull apart one layer from the next one than to completely rip open a certain layer. It's a difference of how the tensions are held on this point. And as Jeremy said, when you have holes like this and the pin is supposed to be sitting off like that, you can have the pin's exerted force going upwards, which will completely delaminate these layers and break the piece open. Right. Any other major questions?
So I have a question for you, Alexander, with regards to modeling. So a lot of the models are STLs. Are you able to pull in an STL to create a CAD model?
Yes, let me see if I have one on hand. You can insert mesh, and oh, I can actually import my old STL files. The STL files are defined differently from a programming and memory standpoint, so I don't really recommend working on them. Personally, I would rather redo this thing from scratch than use the STL file. But if you want to use the STL file, when you import it, it's going to be a mesh body. You can right-click, do not capture design history, and convert the mesh to BREP, this option right here. And this is going to convert it to a native Fusion format so that you can do all of your extrusions and fancy sketches on it. I'm going to capture history again. And if we work, for example, on just the mesh body, if I hit extrude, there is no surface defined on it. There are plenty of triangles because that's what an STL file defines, but there is nothing for the Fusion to do on this. Not even, I think you have body intersections.
Yeah, I think it's important that we make this point clear because this has come up quite a lot and we struggle with this. Essentially, to go back to your question, yes, you can bring in mesh objects as you're seeing here, and you can convert them. Now, if you tried to pull in something more complex like a palm or, some of our fingers even, they have so many facets in the meshes. There's so many different faces that when you try to convert them, Fusion can't even handle it. It won't do more than, I don't remember what it is, 10,000 or 12,000 faces or something like that. Not to mention it would be extremely hard to compute anything on it if you did try to convert it. But even those that you are able to convert, it's going to be very limited, as Alexander was showing, in terms of what you can do. So the best option is always going to be bring in the mesh, just like he did here, but just use that as a reference to then build over building fresh geometry. So create a new sketch, extrude the sketch, basically build like you're building from scratch, but using this as a reference to build over.
Okay, so there's no clear way to bring it in as if you're working on a CAD
there are
file.
there are paid tools that claim to be able to do a better job of that and stuff, but I haven't found a good free way of doing it. If anyone else has, please share, but I haven't found a good alternative to just building clean, fresh geometry. Not to mention, when you do that, if you were to build clean geometry over this, you're going to then have that history of everything you're doing as you build it. And like Alexander showed, you can then later go back and make changes or modify it, things like that. So you get a lot more functionality in the end than just having a solid body, even if you could do a clean conversion.
Okay, so there's no way to convert it into a step file or an IGES file and bring it in as a solid model.
Not the way you
That
would
way.
want. I mean, you can
Okay.
convert it like he just showed you, but you're going to end up with a whole bunch of these little triangular
Triangles.
faces that
Okay.
don't necessarily match up with what you would have created if you had done it as a CAD model.
Yeah.
So it's just a
Okay.
And
lot
this
harder
body,
to
for
make
example,
work.
I think has about 50,000 faces.
Yeah, and that's
So
what I was afraid of. I was just wondering if there was something I was missing in the program. So you confirmed, you know,
Yeah,
my
it's a real
speculation.
challenge. It's a real
Yeah.
challenge. We've got some people like Ward, one of our volunteers, is actually working on rebuilding one of our designs in
Yeah.
Onshape. And, you know, hopefully we can get others that'll do that, you know, take on a particular design. And, you know, we're going to have to rebuild them for those that don't have the CAD files available. But then, you know, it's something you only have to do once, you know, and then
Right.
we can share those files and it'll make it much easier for people to, you know, innovate from that.
Perfect. Thank you, guys.
Yeah.
There are also two other issues with importing STL files. Number one is, well, is really the reason why you can't use them properly in Fusion 360, which is an STL file is a giant list of triangles that are supposed to be connected together to form a surface that has an inside and an outside. Now, because the STL file inherently is supposed to have an engineering error of plus minus whatever you defined when you exported it from your original software, that also means that some of the triangles might not be properly forming a surface. So you're going to have various issues and various nooks and crannies within the design. There is also, you can, technically speaking, you can work with this surface where I have presented the solid menu and the sketches. But there is also a surface working menu, a sheet metal working menu, and various other tools for either 3D printing or for working with very specific surfaces and biological looking designs. This is technically a surface, and that's what that symbol means, but that requires very advanced knowledge to actually use it. The second issue that I want to mention is Fusion 360 doesn't use triangles inherently. Fusion 360 uses these sketches and surfaces. And what that means is that a single surface can be a huge number of points with a huge number of properties. And when you try to convert an STL file to a Fusion 360 file, each of those triangles is treated like a world of possibilities. So each of these triangles in Fusion's mind could actually be a lot of bending, a lot of endpoints, a lot of various properties, which the STL file doesn't actually have, but Fusion thinks it could have. And because of that, when you import STL files that are really big, it could crash your computer. For example, I have a beast of a computer, and I have imported from a site called Z Anatomy, a full body anatomy of a human, skeletal, muscle, and skin, plus veins. And these are just the hands, and it's already making my computer run really hard. As you can see, there are a lot of meshes in here, I think about 500. And if you try to render all of them in Fusion, just render, no options on them, just move them around, it's probably going to require either a very powerful computer or it's going to crash the entire thing. So with very advanced STL files, you don't want to use them in Fusion 360. You're better off even taking pictures of them and using them as such. Do we have any other questions, or should I be approaching my end?
Just time-wise, we are at 20 after, so we probably should think about wrapping up soon.
Right.
I do have a real quick question, Alex.
Yeah.
I downloaded a free version of Fusion 360. It looks
Right.
like it's a 30-day trial. Is that how they work? You just renew them if you want to just play with them for a while?
If you download without making an Autodesk 360 account, you have the 30-day trial. If you make a 360 account, you have to declare why you're using it. And it could be with a university. It could be for free personal use, which is the license that I am having. It could be as a student, as a teacher, as a presenter, as a whatever. And for all of those things, as long as you don't sell these models, you are licensed to use Fusion 360 for free.
Okay, I did it as a personal use and it still has a timeout of 30 days, but maybe I did something wrong. I'll connect with you offline.
Yeah, that's perfect.
Okay, thanks.
All right, the last few bits that I want to mention, where exactly would you go for help with Fusion 360? Now, because Fusion 360 is in the world of CAD software, this Fusion 360 is actually the new kid on the block. It's only about 20 years old compared to SolidWorks, which is about 50. And it has only caught proper grip in the community about maybe 10 years ago. And it's new, it has a lot of new possibilities, but if you want to ask, they have an official YouTube channel that does not daily streams, but I think weekly streams with various questions and various tutorials and updates on the software. It has a lot of recent updates. If you don't like the official channel or you feel that's too advanced for you, there are a lot of communities on YouTube that can that have tutorials, and you just have to choose your fit. Choose which one you're you feel it's most friendly to you. You can also use Google. There are a lot of forums online that talk about solving various Fusion 360 problems. There are even ones where you can post the Fusion 360 native files, and they can return to you with the fittings. And you can also directly ask on the e-NABLE hub. Me and there are plenty of other probably more skilled engineers on the e-NABLE hub as well, or just have a post on the stream if you don't know who to ask. And this is just a list of possible future streams, since this stream hasn't really been as structured as I would like to be. And there are a lot of subjects that I would love to go into detail, and some of you might actually like. We're probably going to post a list of this and have people comment on it in the mainstream on the hub. Right. Any other questions or closing remarks?
For anybody who
Great,
has
thank you.
direct questions about this presentation, you can also comment on the post in the hub for the event, and just tag Alexander's name.
This was very
Okay.
useful. Thank you.
Yeah, it was great. Thank you so much, Alexander. I hope to see people following up in the hub with more questions, and we'll make sure everyone has the link to the recording. I'm going to go ahead and bring